Here's a little picture. I think a lot of people, when they see these pictures, like, so we're gonna look at a derivation of a formula. We're gonna derive a formula. And I think a lot of people are like, look at that, and they think it looks really hard, and they kind of say to themselves, like, how would you ever know to do that? Well, I mean, you wouldn't. Like somebody sitting in a high school math class wouldn't know to do that. But this is the kind of thing, like, to derive a new formula, you have to like come up with a picture and start thinking about the connections in there, right? Like, that's just how it goes. It's not like there's an obvious way to start this. So we're starting from a point that somebody else already made up, right? So don't think that there's some intuitive nature to this formula, right? That being said, once you have this picture, if you know the general idea about how the formula is made, you should be able to do the algebra part of it, right? Like, the algebra part should be easier-ish for us to follow, especially at this point. So given the picture, then maybe we could do it. Same thing with like the sine law and the cosine law. Did you ever see how those are derived? Have you seen that? Anybody? No? Not really? That's too bad. They're really simple, and again, really, they're like just neat little sort of ideas that somebody came up with. And again, once you have the picture, coming up with the laws is not too bad, or the formulas is not too bad. Okay, so here's our picture that we're starting with, and I would maybe look at it again in a little bit more detail later if you get a chance. It's just got 2 points on the unit circle, okay, and so this is a radius and this is a radius, right? And not that that's necessarily important. It kind of comes up later, but they each have length 1, because this is a unit circle of length 1 with a radius length 1. Okay, and so we just kind of make some angles. So there's angle B, there's angle A, all the way around. So that makes this angle from this terminal arm to this terminal arm between the two, A minus B, right? The big angle minus the smaller angle gives me A minus B. So it's kind of like everything we've done so far is with angles like A or B, right? Always back to that starting arm, the x-axis, right? Everything we've done has been angles in standard position. This is not. It starts in standard position, but now it's an angle between two terminal arms. So it's different, right? So how would we find some relationship for that angle, which is A minus B, okay? And then I think it's interesting to think about how when I have a point on a unit circle like this, the coordinates, cos B sine B and cos A sine A, the B is the angle, right, of the terminal arm to that point. So like you can figure out, if you have that angle, you can figure out the point on that line, then you can figure out other points if you wanted to. Anyway, so some of that kind of comes into play. Okay, so that's just the picture we're working off of. We'll take a look back at that momentarily or every so often. From the cosine law, if you remember cosine law, you learned this in grade 10. C squared equals A squared plus B squared plus 2 minus 2AB cos C minus. Right? That's the cosine law. How do you know to start with cosine law? Like, again, you don't, right? This is like, I mean, in a triangle like that, you might think, well, if I'm looking for this, that has something to do with the cosine law. But, again, this is a thing that's already been made up, right? So we just know that cosine law is going to be part of this. So it's, again, that should be minus. So it's the length of A squared, so 1 squared plus 1 squared plus 2 times 1 times the cos of the angle between them, which is A minus B. So just subbing in values from that picture. 1 plus 1 is 2 minus 2 cos A minus B. Okay, so we just simplify that sort of as far as we can and then stop. That's it. Then we use the length formula. You also learned this in grade 10. See how important a year grade 10 is? You learn so many of these key ideas in grade 10. Length formula. So the length between any 2 points on a Cartesian plane comes from Pythagorean theorem, right? So the difference between the x value squared plus the difference between the y value squared, and then I take the square root. It's from Pythagorean theorem, if you don't remember. And my x and y values, this is like this, right? Between these 2 points is what we're looking at. So what we've done here is this first part is an expression for this length up here squared. And this is also an expression for the same length, although it's not squared yet. So it is the square root of those coordinates that I just talked about, sine A minus sine B squared plus cos A minus cos B squared. The x values plus the y values. So cos and sine and sine. Is that all good? That's the setup, I guess I would say. Then we're going to do a little bit of, like I said, algebra. And this is something that we're going to go through quickly, but it's something within your skills to recreate, I think. Square of both sides, so I get c squared, and it gets rid of the square root on that side. And what's sine A minus sine B all squared? Sine squared A minus 2 sine A sine B plus sine B squared. So that's the first binomial squared, right? A plus B squared, A squared plus 2AB plus B squared. Also from grade 10. And then the second one, cos A minus cos B all squared. Cos squared A minus 2 cos A cos B plus cos squared B. A squared plus 2AB or minus 2AB plus B squared. That is no different from doing something like this, x plus 3 all squared, just with sines and cosines. Okay, so simple algebra. Rearranging a little bit, this is where a little bit of our trig identity stuff comes into play and is helpful. Do you see where the trig identity is? Sine squared A plus cos squared A, sine squared B plus cos squared B. Those are both 1. So in the next line, we replace them with 1 and 1. And then I've got minus 2 sine A sine B minus 2 cos A cos B. Just worked out that way. So 1 plus 1 is 2. And then minus all the rest of that junk. Nothing else we can do with that right now. It's just still there. But what do I have? I have 2 things. This is equal to c squared, and this is equal to c squared. If they're both equal to the same thing, then they must both be equal to each other. That's a fairly simple concept, but very important in a lot of proofs in mathematics. And it's an easy piece of logic that can be very powerful. So 2 things that equal the same thing equal each other. Therefore, this is the first one from the cosine law. This is the second one that we just did, right? So what happens here? Well, I get a 2 on both sides, so they're both gone. Okay, so I just got rid of them. And then I divide both sides by -2, so that -2 is gone, that -2 is gone, that -2 is gone, it turns into a plus. And this is what I'm left with, our formula. Cosine of A minus B is equal to sine A sine B plus cos A cos B. So all of that, again, given the picture and knowing that you start with cosine law and length formula, the rest of the algebra is fairly easy. And now we have a new formula. You need to know the formula, but it does help to have some understanding of where this stuff comes from so it just doesn't seem like magic, I think. Any questions about that? So new formula to memorize, yay. And let's see if we can, so that's a formula for cosine of A minus B. Can we develop a formula for cosine of A plus B? Can you do that by yourself? You can if you start from this. It's not so bad. So let's give it a try. Okay, so cosine, so you're going to start, you can start writing this down. Oops. So I'm going to give you the first step. Cosine of A minus negative B. So now this is the formula of A minus B, except instead of B, it's negative B. If you prefer, it can get a little bit confusing with all the B's and some of them being negative. You could turn this into a C. And what I want you to do is plug it into that formula. So wherever you see a B, you actually put it in negative B, or you put in a negative C, if you want to do that. And then think about it for a moment. I'll leave that there too so you can write it down. Okay, so far we should have this cos A times cos of negative C plus sine A times sine of negative C. But we can't have the negative in the C. So what I want you to remember from yesterday is, what do you know about even and odd functions for sine and cosine? Okay. Okay, so hold on. For cosine, cos of negative C is the same as cos of C. That's what you just said. Awesome. Because it's an even function. Very good. See how useful that is? Okay, do you want to go on? So times negative sine of positive C, like that, right? Which equals cos A cos C or cos B minus, right? That negative, it's just times a negative 1. So I can pull that out to the front, sine A sine C. So this is how we would summarize this. Cosine of A plus or minus B equals cos A cos, put brackets around that, cos B minus plus sine A sine B. The plus minus sign is flipped, and that's like important. Has to be that way. So in other words, when it's cos of A minus B, you end up adding so it's flipped, right? So the plus sign here goes with the minus sign on top, and the minus sign on bottom goes with the plus sign on bottom. So you got to remember that for the cosine law, not cosine law, but for these are called compound angle formulas. So for the compound angle formula for cosine, signs are switched. Got to remember that. Okay, and then I'm just giving you the rest of them. You can write that down, and we're going to do a couple of examples. Sure. This one's written backwards, sorry. Doesn't match what we have on the other one. So this should be cos A, cos B. You're subtracting the sine. So we're not going to derive the sine compound angle formulas. Never say never, but would I randomly ask you to derive the sine law on a test without ever having seen it before? Probably not. Maybe as a bonus. But again, deriving formulas, like I said, either takes a long time of like an inspiration, a eureka moment, that happens, or like a lot of scribbling and trying things and drawing things and trying things that don't work to eventually come up with a formula. Like there's lots of other formulas that are just maybe not very simple or not very useful, not very nice, so we don't use them. So to find a nice one that's a bit simpler can take a long time. But if you know where to start, if you've seen it before and you know where to start, that's different. Still, deriving a formula is not something you would be asked to do typically on a test like as a main question. Bonus, yeah, maybe, if you've seen it before. I've definitely asked those in grade 10, like derive quadratic formula or the cosine law. Have you seen the derivation of the quadratic formula? Did you see that at least? Yeah. So today we're only doing the cosine and sine compound angle formulas. Tomorrow we're going to look at the tan compound formulas. So you've got them written down, but we're not going to use them today. These are also in the textbook on page 399, right before the practice starts. If you ever need to look them up, it's useful. All right, let's get started. So here's how the compound angle formulas are useful. What is the sine of 15? That is not one of our special angles in our special triangles, is it? Special triangles have 30, a 60, and a 45. No 15. So up until now, 15 it would be an angle that you would just do like not as an exact value. Sine of 15, punch it into your calculator, and start working out the rest of the details. Right? But What do you notice about 15 and its relationship to the special angles that we do know? So we know 30 degrees, 45 degrees, 60 degrees. We also do know like 90, 180, and then all the other ones too, right? So 120, 135, those are fair game as well. We can do all those. Chad? Yeah, very good. It is a factor of each of them. What else? A plus B, A minus B. What is A? What is B? They're angles. Go ahead, Jed. Okay, not sine of 60 minus sine of 45. So hold on, that's a really good idea. I'm just going to pick on that for a moment because this is something that's interesting to think about. So the sine of 60 minus 45, if I put that in brackets, whoops, I didn't want to do that, I guess. Sine of 60 minus 45, is it equal to the sine of 60 minus the sine of 45? That would be nice. That is not our formula, right? We don't know that's true. We can't make stuff up. So this part isn't correct, but this part, that's the good part. Isn't that the sine of 15? If I put that in brackets, isn't that the same thing? Can I rewrite 15 as 60 minus 45? Do you agree with that? Do you believe that's true? Sine of 15 is equal to the sine of, in brackets, 60 minus 45, or 45 minus 30 would work as well. Believe that? So what does that mean? Well, the sine of A minus B is right there. It's the sine of A cos of B minus cos of A sine of B. So that's not our formula, but we do have a formula that will work for this. So equals sine of 60 minus 45, which equals, so I'm using sine A minus B, sine of 60 cos 45 minus cos 60 sine 45. I should point out, notice how cosine, it is tricky. Like you've got four formulas. Now the formulas are all quite similar. There's a lot of similarities. So that makes it easy to remember. They have the same structure, but the specifics are different and obviously important that you get it right. So if I look at the cosine ones, cosine of A minus B and A plus B is cos, sine, sine. And the plus minus is flipped. And the sine of A minus B is sine, cos, sine. And the signs are the same. So A minus B, I'm still subtracting. A plus B, I'm still adding. Probably would kind of figure out those patterns on your own, but that's, I think, a good way of like memorizing that part of it as opposed to memorizing the entire formula. So cosine is cos, sine, sine, and sine is sine, cos type thing, like one of each. Okay, so sine, cos, and so this equals, what is the sine of 60? So now we got to do a lot of special triangle stuff. So this is where, if you've got the special triangles drawn out on that little cheat sheet from yesterday, would be helpful. So there's my 60 and my 30, and 1, 2, root 3. So sine of 60 is root 3 over 2. Cosine of 45 is root 2 over 2. I'm going to write it that way. We're going to get used to just writing it that way, not writing it 1 over root 2 and then flipping it. Yes? I don't think so. I think it's good. Because this is a smaller angle, so it should be across from the smaller side. I drew it rotated from how we sometimes draw it, but I always try to think of how long it, like 1 is less than this, is smaller than the square root of 3, so it goes with the smaller angle. Okay, cosine of 60 is a half, and sine of 45 is again root 2 over 2. What's root 3 times root 2? It's the square root of 6. So square root of A times square root of B is equal to the square root of A times B. That is something that is true, something that we know. You could look at exponent laws to remember that that's true. So that's something you should have seen. Minus root 2 over 4, which is the square root of 6 minus the square root of 2 over 4, and that's done. That's what that would look like in the end, as far as you can go. Of course, if for some reason you needed a decimal answer, you could punch it in and do that, but any questions? Are you sure? Any questions? Any questions? I hate to say it, that's the easy part when you're doing it in degrees. Most of the, like some of them in the practice are degrees, but the radians are the ones that we want to get to, and that makes it a little bit trickier. Because we don't picture radians in our head the same way and the fractions the same way. It's not as easy to figure it out. Now that you've seen it once, figuring out two angles out of the special angles that add or subtract to 15, or if I gave you a different one, like 110 or something, I don't know. You know, you could figure that out probably pretty easily, but with radians, it is trickier. So I'll give you a few strategies. We'll do this off to the side here. If I have A plus B equals C, or if I have A minus B equals C, like how do I figure out two things that add or subtract to pi over 12? First of all, I would think of it as 1 over 12. We don't need to worry about the pi. So this one can be A equals C plus B, right? So move the B over. Or A minus C equals B. If this doesn't make any sense, it will in a moment. And this one could be A equals C minus B, or obviously C minus A. It doesn't make a difference. So C is that guy. So if you don't see it right away, like you might get used to some of these. You might see it fairly quickly, but if you don't, you take C and start subtracting the angles that we know, the special angles, or start adding the special angles until you get another special angle. Does that make sense? Our special angles would be things like pi by 3, pi by 4, pi by 6, 2 pi by 3, 5 pi by 3, 3 pi by 4, 5 pi by 6 maybe, right? Those guys. Those are the ones that we're looking for. Once that comes up, I can use that with all the special triangle stuff we did in the last unit, figure out those exact answers, and use them in here. Does that make sense? So our first goal is to figure out two angles that we can actually find the exact value for that add or subtract to pi by 12. Does anybody have an idea? Does anybody have an idea? I'll give you a couple more to start. Get your calculator out and start trying. I mean, this is up to you to be able to do this. I'll give you another idea. If I'm adding two fractions, how do you add fractions? With a common denominator. If your common denominator is 12, what do you think those fractions started as? This is not a hard rule. It doesn't always work out this way. But what do you think the denominators might be? Chad? You know what the answer is? Just in general, what do you think the denominators might be if my common denominator is 12? Like, well, 2 and 6, but 2 goes into 6, so.
4 and 6.
Could be 4 and 6. Yeah, because they multiply to 24, but then could simplify to 12 and have a common denominator of 12. What else? 3 and 4, right? So start trying combinations of those things. Pi by 12 plus, or 1 over 12 plus 1 over 3. 1 over 12 plus 1 over 4. 1 over 12 minus 1 over 3. Like start trying things. I'll give you one other little tip. This only works in some cases. But how should I do this? 1 over A plus 1 over B equals A plus B over A times B. Like when it's a 1 on top and you do common denominator stuff, that's just always how it works out. And it's the same for subtracting, although it's a little bit wonkier for subtracting. So I'm not going to write it out because it has to do with which one's bigger. But anyway, okay, so it's kind of the same for subtracting. So when I look at this one, I do see a 3 times 4 on the bottom, and I see a 4 minus 3 on top. 4 minus 3 is 1. Right? So pi over 4 and pi over 3 will work. So I would do this like this. 1 over 3 minus 1 over 4. 1 over 12. The bigger one minus the smaller one. Again, even just visualizing the size of fractions, knowing that which one's bigger can be useful. 1/3 is bigger than 1/4. There's I don't know if this is even true, but there's this famous story, a little anecdote that I think it is true. I don't, like part of it's true at least. McDonald's, the quarter pounder, the famous quarter pounder. I guess they came out with a 1/3 pounder at one point, like a bigger one. So it was 1/3 of a pound as opposed to 1/4 of a pound. It was bigger, so it cost more. But people complained that it's only 1/3 of a pound. 3 is smaller than 4, so the burger's smaller. But it costs more, so nobody would buy it. Because people don't understand fractions. That 1/3 is bigger than 1/4. Anyway, I don't know how true that is. But it makes sense because a lot of people in the world don't understand fractions, that's for sure. All right, so let's get on with this. Cos of pi by 3 minus pi by 4. All of that was to be able to get that compound angle. Pi by 12 is the same as pi over 3 minus pi over 4. My last tip before we go on and do this, you can give this a try, but I think you want to listen. You can also, I don't want to see you doing this on a test, but on scrap paper would be fine, or in your head if you can do it would be fine. You can also realize that pi by 12 is 15 degrees. So it's the same question. 60 minus 45, 45 minus 30 will both give me 15. If it helps you to convert to decimals, or to degrees, and think of it that way to find your angles, sure, by all means go for it. But don't like do it in the question. I want to see radians on paper. So do it in your head or do it on the side. All right, so go ahead and rewrite this with our formula. So remember, cos is cos, cos, sine, sine, and the sign changes. Go ahead, keep going. What's the cos of pi by 3? What's cos of pi by 4? Use your special triangles. Root 3 over 2 times root 2 over 2 plus 1/2 times root 2 over 2, and it gives me root 6 plus root 2 over 4. Very similar to the other ends. You're going to notice some common sort of answers. This plus this minus this. Happens a lot with these questions. What do you think? Any questions, any questions, any questions? Should we keep trekking forward? Okay. Cos of 7 pi by 12. What is it? Very good. Three plus 4 over 3 times 4. So that could be an easier-ish kind of one to notice. Even when you just skim through the textbook, you notice there's a lot of the same. Like there's no really crazy hard ones, I don't think. There's a couple that are a bit more challenging, but overall, they're fairly straightforward. So this is equal to the cosine of pi by 4 plus pi by 3. And again, like this might seem like a lot of work and really hard, but you'll surprise yourself. You're probably better at special triangles now than you realize. And once you have to do it 4 times per question, you get really fast. And I mean, we already found, in those 2 questions, we already found pretty much all of the special angles, right? Once you see 45, root 2 over 2. Like it's so, like it happens fast with no thinking. Once you have to use it for something else. This is when you really learn something, when you're using it to do something else. Okay, so go ahead and try this one. Like this is all the same fractions as the last question. Root 3 over 2, root 2 over 2, 1 over 2, root 2 over 2. So it's root 6 minus root 2 over 4. Don't always try to do that in one step. But in this case, since we've already seen it, you might be able to. Okay, one more. I'm going to give you a minute to try this one. And what I want you to do is, so it's negative. Don't overcomplicate it. Don't try to get two negative ones and add them together or something weird like that. This is going to be sine of a minus b, where a is smaller than b, right? But also, what I would try is I would come up here, and this blue one right here, a minus b equals c. If b is bigger, it's going to give you a negative number, so that's what's going on here. But how do we figure it out? A equals c plus b. So if I take c, which I know, it's 5 pi over 12, negative 5 pi over 12, and I start adding stuff to it, I'm going to try to get a. So negative 5 pi over 12 plus pi over 4. Negative 5 pi over 12 plus pi over 3. Negative 5 pi over 12 plus pi over 6. Try. So give that a try for a minute. Okay, if you didn't get it, that's okay. We don't have a lot of time left, so we got to keep trucking. This is the last example anyway. So it ends up being pi over 3 minus 3 pi over 4. Give it a try. If you're doing that a plus b, a minus b thing, I would also recommend to always, like, to get make sure your signs are right and you haven't flipped any of that stuff, unless you really get it and really can understand and picture that stuff in your head. Double check by trying what you come up with. 1 over 3 minus 3 over 4. Make sure that gives you 5 over 12. And it does. So what does this work out to? What's the sine formula? Sine, cos, and the sine, plus minus sine, is the same. So sine pi over 3 cos 3 pi over 4 minus cos pi over 3 sine 3 pi over 4. Sine of pi over 3 is a half. Cosine of 3 pi over 4. Cast. 3 pi over 4 is in the second quadrant, so it's going to be negative root 2 over 2 minus cos of pi over 3, which is root 3 over 2. And the sine of 3 pi over 4 is positive in that quadrant, so root 2 over 2. If I simplify this, I get negative root 2 over, minus root 6 over 4. So that could be negative, like factoring out the negative, root 2 plus root 6 all over 4. often the textbook would factor out a negative like that and write the answer that way. So my rule is like, do you have to? Well, not really. It depends on what you're doing next. There's no rule that you have to factor